Hello, welcome to another Houdini session. My name is Gianvito Serra, and today we're going to learn how we can use attributes and also groups to some extent to actually be able to identify parts of geometry and be able to modify it as needed. Okay, it's a very typical thing that sometimes we use attributes not as a means for a user to manually paint something or to identify something. But sometimes, we actually use certain attribute operators to deterministically figure out when something falls into a particular category or not. Okay? So what we have here is actually a tree model, which I kind of made up for this particular exercise, but the idea here, the story here is that I basically have this tree, okay? It's an object file, okay? So it doesn't have any history behind it or anything, it's just baked out the way it is, okay? The art director wants to come in here and put a certain amount of noise on the actual main trunk. He wants to also get a little bit of noise, a different type of noise along the little branches, and he wants to replace the leaves, every single leaf, with a better leaf model. Okay. So the first thing, so when we presented with this kind of problem in Houdini, there is many ways that we can go about identifying the components of this particular static model using attributes. Okay, so let's begin. So to begin, we're going to start with, okay, so the first thing that we want to do is to actually create an attribute that basically identifies every component that we see here with some kind of ID or something. Okay, by component I mean polygon islands. So the idea here is to actually start creating a separation where, like, for every leaf, I'm going to have an attribute. For every branch, I'm going to have an attribute. So it's very easy to then, start breaking these things up and starting to look into the rules of those particular assets. Okay. So for that, we use a connectivity sub. Okay. Connectivity sub is a very useful operator, which allows us to create attributes which we can see for every island. Okay, to make this a little bit simpler, what we're going to do is that we're going to go ahead and actually separate this panel from top to bottom. So we'll do split panel top to bottom, and then for this one we'll go ahead and bring a geometry spreadsheet. Okay, so this will allow us to see on the nodes that we have selected, what our attributes are looking like as we're actually creating them. Okay, so here is our tree. We created a connectivity attribute, and as we can see, something changes from this node to this node. Okay, we have this attribute called class. I'm gonna go ahead and actually call this polygon island. Okay, and I'm gonna make the connectivity type primitive. Okay, so what that does is that it's going to make this attribute a primitive type. So if we middle mouse, we'll see that now I have a primitive attribute called polygon island. Okay, and if I go to my primitive attributes, you'll notice that now I have an attribute called polygon island. You can see that every face on this particular asset has an ID associated with it. Okay, so just to make that a little bit clear, I'm going to create a visualizer so that we can see that a little bit better too. So I'm going to go to my display options by just clicking on the viewport and pressing D. I'm going to go to visualizers and create a scene visualizer that is going to be a marker type. Okay, and I'm going to call this polygon islands. Oops. So I'm going to call it the same as the one that I had here, and then I'm just going to use the same name here. Okay, and then I'm going to go ahead and use a text one. The attribute I'm going to choose is going to be from this. It's going to be a primitive attribute, and it's going to be the polygon island attribute. Okay, and there we go. So now you can see that when this is on, we see a lot of numbers show up on top of our meshes. Okay, but most importantly, you will notice that branches have unique numbers. Okay, and we're going to even the sub branches here, and each leaf has a unique number, and each sub-branch has a unique number. Now, it's not every face that has a unique number, it's every branch, okay? So we're starting to make a classification which we can use to very easily isolate the pieces. I'm going to turn off my visualizer for now so that we can go back to just seeing this. And let's go back over here. Okay. So now that we have the polygon islands, or the IDs for each polygon island, what I want to know is, I want to try to identify the main branch of this tree, okay? Like, so the actual core branch that goes from top to bottom, that all the sub branches come from. And that will, if we think about it, that will be the one that will have the most polygons of this whole mesh, okay? Every leaf has about 1 polygon. Sub branches will have like a few polygons. The main branch in this case, however, will have probably the most polygons, okay? So what we can do is, because we have every one identified as with an ID, okay? We'll sort this by the polygon island attribute. All that we have to do is find the one ID that is repeated the most, okay? The one that on this whole mesh is mostly used, which will give us our biggest polygon island, okay? For that, all that we have to do is to create an attribute promote, okay, as in promotion. And I'm going to come here and say that my original class is primitive. And I'm going to explain a little bit in a second what this does, but I'm going to switch my class to primitive, my new class to detail, and I'm going to set this to, I'm going to, actually before I do that, I'm going to pick the attribute polygon island, okay? I'm going to go ahead and keep the original, and I'm going to change the new name to polygon island mode, okay? It will look like we still have our polygon island here, but what we have here, if we click on this particular tab right here, is now a detail attribute called polygon island mode, which is what I created here. So what attribute promote does is that it actually grabs all of the actual attributes that are given, or the attribute that is given, and you can actually change it from being a primitive attribute to being, say, for example, a detail attribute, or from being a point attribute to being a primitive attribute. It's just a way for you to actually move attributes in between different component types. So, for example, if you wanted your colors not to be on the points, but you wanted your colors to be on the primitives, you can use attribute promote to actually promote your colors for every primitive, okay? Now, in some cases, because you're promoting something, you may end up having a situation where you have to choose how do you deal with classes, okay? So, for example, if a primitive has 3 points, and you have 3 colors, each one of them has 3 colors, what color do you choose as being the one that goes into the primitives, okay? So you have several ways that we can do that. Average is the default that we have here. What we can do, so for example, we can do the maximum, okay? And you can see my polygon island here is changing when I change it here. I can do the minimum, so that's my lowest polygon island ID. We can do the median, okay? We can do the sum, so where it adds all of the numbers together. But most importantly, we can do the mode. Okay, so what the mode is the most popular attribute. Okay, so if you have, say, for example, a circle which has 100 points, and you want the most popular, the color that is mostly used on those points to be the one that the circle is color, you will use mode. Okay, it's like the same as the French word à la mode, which means in the matter of. Okay, so by doing this, now we have an attribute that is the polygon island mode. Okay, so now that we have this attribute, we can use a blast operator to filter out polygons that are within that particular polygon island. So if we go back to my polygon, okay, we're gonna try to find basically all the polygons which are on polygon island 0, which is the most popular, okay? The way how we can do that is that, some of you are familiar with the idea that we can actually use groups to actually blast things or to filter things in operations, but we can also, if we want, use attributes, and this is how we do it. You can use attributes by simply putting an @ sign and giving the attribute name. In this case is polygon island. Okay, this is creating a reference to the attribute, and then what we can do is say polygon islands equals, and then we want basically to find every polygon, every face where polygon island equals that polygon island mode attribute. Okay, so for this now we need to make an expression to reference that detail attribute which we just created. Okay, and if you remember from our previous lesson, you can actually use expressions to refer attributes. In this case, you will use a detail expression. And the way how the syntax works for this is that you start with the word detail, and then you want to give it an operator name. So we can use, in this case, attribute promote 1. Promote 1, there we go. We can also then, we want to say that the attribute name is polygon island mode, is what we called it. And then 0 at the end just means that it's the first index. So if for some reason your attribute was a vector, you will have 0, 1, and 2 available. In this case, it's just a single value, so we just leave it at 0. Okay? There we go. Now you notice that immediately something changed. Now we're actually deleting the main branch. Okay? So that's good. We're able to identify it. All that we have to do to actually keep the main branch is to simply turn on delete unselected. Okay, so let me copy this expression over to a little note, and we can see a little bit better and a little bit more clearly what's going on here. Okay, make this a little bit bigger. So the first part of the expression is the attribute. Okay, in this case, the attribute that we're looking for, they're doing the search on, is polygon island. So we're saying, okay, find an attribute polygon island. Okay, which we have on our mesh. Then we're saying, now, okay, find every polygon, every primitive in this case, where polygon island equals something. Okay, it could be equals 0, it could be equals 10, it could be equals whatever we want. Okay, even if I came in here and I put 0, this will still work. But watch, we can even change this number, and you will see like different parts of a tree will get highlighted every time, right? As we're actually switching to the different items of a tree. Okay, but we know that 0 is our largest island in this particular case. Okay, using the detail expression is just making it so that we are not just coming in with an arbitrary attribute or an arbitrary number, but that we're using an expression which chooses a value that was determined by the attribute promote. Okay, by using it in mode. And the way this expression works is that detail is pointing to a natural detail attribute, one of these guys. And then I'm looking for a node called attribute promote 1, this guy. And I'm looking for an attribute called polygon island mode, which if we move the mouse, we'll notice that we have a detail attribute called polygon island mode. Okay? And we're looking for the first index, which is 0. In this particular case, there's only one channel for this. Okay? Very cool. So moving along, now we have the main branch. Okay, if we want to, we can even Control C this and then Control V to copy and paste it, and then we can turn off the delete unselected flag to get the rest of the tree. Okay, so that's good. We have now identified the main branch, and we're gonna just put a null node here to let us know that. Okay, so null. And I'm going to call this null node. Null, we'll call it null underscore main branch. Okay, and then let's go over here. So the next step is to identify some of the rest of the pieces here. Okay, I think what I'm going to do next is to actually isolate the leaves. Okay, if you look very carefully at the leaves in this case, they're basically all single polygons. Okay, which have, edges. Okay, so they have about 6 edges each, which is the thing that really makes them different from these branches. I mean, there is a lot of reasons why these leaves are different than the branches, But in this particular case, this is probably, I'm going to use the fact that they are only border edges to actually make their identification, okay? And then, like I mentioned before, there is a million ways to do things in Houdini. For this exercise though, because I want to show you how to do this with groups, I'm going to actually use this method, okay? So if we look at these leaves over here, for example, you will notice that we have the leaves and then we have the branches, okay? The biggest difference that we have in between, one of the biggest differences that we have in between the two is the fact that the branches have edges which are internal, okay? You have edges that share faces, whereas the leaves do not. I mean, the leaves are basically all border edges, if you will, okay? So identifying them or isolating them with is pretty easily done with a group sub. So if we press tab, we'll add a group operator. Okay, I'm gonna call this group border edges or borders, and we're gonna switch it to edges. Okay, so I'm gonna turn off number because we don't care about that. Okay, almost there. And then we are going to turn on edges, okay? And we're gonna turn on in the edges tab the option on share edges, okay? Which will highlight or select anything that is a border edge. So as you can see, we're already picking up a lot of the leaves, which is awesome, but we do have a problem. We're also picking up all the border edges on the branches, which is not ideal. Okay, you can even see it right here, you know? That's something that fortunately we can also fit quite easily. In the group sub, we can also convert any type of group from being, say, an edge group to a primitive group. For middle mouse right now, you will notice that we have an edge group, which is the border edges, right? So what I want to do is this. I'm going to use a little trick here, where I'm going to go to the edit tab, and I'm going to go to convert, and I'm going to convert this group from an edge group to a primitive group, okay? I'm gonna pick my group here, and now look at what happens. So now my edge group is converted into primitive group, so my leaves are selected, but my end branches are selected too, okay? But that's because I haven't turned on this flag, okay? Now if we turn on this flag, you'll notice that they go away. I'll explain why. So if we go back to, if we turn off this conversion, we'll go back to just having an edge group, okay? You will notice that in this particular case, all of the edges in the primitives are selected. In the case of a branch, not all of the edges in the primitive are selected. This flag makes it so that it will only convert a group from edge to primitive if all the edges in the primitive are selected. So in this particular case, if we pick again borders, this flag will select and deselect the bottom edges based on the fact that the edges are only down here, they're not selecting the whole primitives, okay? So that makes it very easy for us to isolate these leaves. Now that we have the leaves isolated and we have them actually in a group, all that we have to do is to use a blast node again to isolate them out. So we do borders, and then we do delete unselected, and here is all our leaves. Wonderful. And then just like we did before, if we Control C and Control V this, and we turn off delete unselected, we end up with just the branches, okay? Very cool. Alright, so far this is working out great. I'm going to put a null node here to remind me that this is my leaves. Okay, I'm going to go ahead and also color them in green, so that way I know I can see where they are, okay? Cool. Okay, so moving on. The next step now is to separate the bigger branches from the smaller branches, okay? And the way we can do this is by simply identifying the branches as, single entities and measuring how much area they take. There is a lot of ways in Houdini, there is a lot of really useful tools in Houdini to create attributes based on measurement of geometry. Okay. Now, before we do that though, we do need to do something that we need to change a few things about our geometry. Okay. If we go to our primitive list, you will notice that every single, when we look at the tree, every single face in the tree is a primitive, okay? So you have 32, 33, 31, 30, everything is a separate object, okay? And that's cool, but the problem is that we need to really make our measurements based on single branches. So we need almost like every branch to be a single primitive entity. That will help us when we do the measurement to actually be able to identify them individually, okay? Again, if Houdini is a very versatile program where you can approach this problem in many different ways. For the purposes of this class, I'm going to show you how to use the polysup operator. So I'm going to drop a polysup, and I mean polysup as in polygon soup, soup like you eat soup, okay? What the polysup operator does, it creates very memory efficient primitives that can be used for rendering, but one very useful thing that it does is that it will grab all of your polygons and make it into a single primitive, okay, by default. However, if you have an attribute such as the polygon island attribute, and you have ignore primitive attributes off, Polysup is going to create a primitive. It's going to create a primitive per attribute so that it can actually maintain the attribute values without changing them. Okay. So in this particular case, it's going to make sure that every single polygon island attribute is preserved by only combining faces if they actually have the same attribute value. Okay. So now watch what happens. If we middle mouse here, you'll notice that we have 648,000 polygons. But if we middle mouse here, you will notice that now we have 8,810 polygon soups. Okay. If we look at our primitive numbers again, watch how every branch has the same IDs. Okay. Now this is different. You were probably wondering why can't you just use the polygon island attribute instead of actually doing this. The reason why is because I do need Houdini to treat each one of these different islands as a single primitive for the next operations that I'm going to do. You can take the polygon island attribute and feed it into, say, for example, a for each operator, which will loop over every single one of those different island attributes. But that can be also very inefficient compared to using combining your primitives. Okay. So this is generally a method that I use often, which I think works very well for dealing with polygon islands. Okay, so long story short, if I come here, I'm gonna put a blast node, which by the way, by default the blast node deletes primitives, and I actually put a primitive number. You will notice that now, we'll go to delete node selected. You will notice that now every branch is pretty much treated like a single primitive, which is perfect. That's exactly what I need on this. Okay, cool. Next step, now that we actually have all of these branches combined into single primitives, is to do a little bit of analysis on them. For this operation, I want to try to get the area of each one of the branches so that I can calculate how big they are. Okay, so for that I'm going to use a measure operator, as in measuring tape, and I'm going to set my parameter type to area. Okay, so now you will see that for every polygon island that I have, or for every polygon, I know the area of a polygon. Okay, very cool. So the polygons that have the biggest area are going to be obviously my main branches. The polygons that have the smaller areas are going to be the ones that have the smallest branches. Okay. At this point, we could probably hardcode a number and call it a day, but we want to try to make sure that we do things in a way that are deterministic, to ensure that if for some reason I get fed a new tree which is very small, the system still can cope with those changes, okay? So what I'm going to do is I'm going to add another attribute promote. Okay. And for this attribute promote, I'm going to switch the original class to primitives and my new class to detail again, like we did before. But I'm going to pick the area attribute this time, okay? And what I'm going to be looking for, I'm going to keep the original. I'm going to change the new name to area mats. I'm going to be looking for is the maximum area. Okay, so I want to know from all of these polygons what is my maximum area, which is this, okay? Okay, so now we have the maximum area. That is as well as for every polygon, each individual area, okay? Now, given those values, now we can actually create an expression to easily filter out the thinner branches, okay? So we're gonna put another blast node here. And I'm going to go ahead and actually put an expression here. So this expression is gonna look a lot like the last expression that I did. But in this case, I'm gonna be looking for the area attribute that I just created from the measure operator, okay? Just to make that a little more clear, if we go back to the measure operator, and I middle mouse here, you will notice that it creates an area attribute, okay? If we go to the polysub, we don't have it there. The measure gave me an area attribute, okay? It can do several things. It can do area, it can do perimeter, curvature, and even volume of the primitives, but for now I'm just interested on the area, okay? I'm gonna go ahead and blast, and then what we wanna do is we wanna pick up any primitives for the area is less than, and I'm gonna go ahead and pick up the detail attribute again. So detail, I'm gonna go to the attribute promote 2. Okay. Then we're gonna pick the area mats attribute, and we're gonna get set it to 0 because we only have a single channel on that, okay? Immediately what you will get if you delete non-selected is that everything is pretty much deleted. Well, that's simply because we're saying that the area is small than the area mats, okay? So what we need to do is to change this a little bit so that it says that is anything where the detail, the area is less than the detail or the area mats divided by, say, for example, 5. And now perhaps we'll go with 10. Oh, I think I know what's happening. Need to make sure I name this actually attribute promote 2. That's the name of the node. You can tell that the node is correct when it's actually brown. There we go. So that will be correct. And now there we go. We have actually isolated the branches, okay? Very cool. Now if we actually do the same thing, and copy and paste this guy over here, we can keep the other ones over here. Very good. Awesome. Let's go ahead and actually put null nodes here to say null. Okay. This is gonna be my null mid branches. This is gonna be my small branches. Oh, let's spell that again a little bit better. Very cool. I'm gonna make these guys green. Awesome. Alright, so now we have actually isolated all the parts of the tree. Good. So now we need to go ahead and add the modifications that the art director has. So he wanted a little bit of noise for the actual main branch. Okay. We'll put in a mountain operator to actually add a little bit of the noise. Oh, that's maybe a little too much, of course. We'll go ahead and actually reduce the height and perhaps increase the frequency just a little bit, okay? Maybe not so much. It's mining too much away what it was before. Okay, reduce the roughness. Actually increase the roughness, there we go. Alright, so that's kind of for new main branch. Alright, just a little bit less. I wanna do the same thing, similar thing to these guys, but because they're little branches, I'm gonna have to use different settings. So I'm gonna use for these guys a little bit a lot less than we had on this guy. Or maybe we'll have a higher frequency. There we go. Something like this. And last but not least, in the mid branches, we'll do something about similar to what we had on the big branch, but about to here. Maybe with a little bit less roughness and a little bit more frequency. Just a little more. There we go. The art director wants us to also color this over here. So I'm gonna go ahead and add some color to these guys. I'm gonna choose a little bit of this kind of brown for this. And we're going to do the same thing here. Oops. You want the same color for the actual main branches, but for the actual, remember Control C and Control V to copy a node. But for the ones that are actually closer to the end, he wanted it to maybe have just a little bit of a hint of green. Okay, a little bit less saturated too. Awesome. Now for the leaves, we got a little bit more work to do. Our director gave us a leaf model, which we're gonna bring in using a. Let me close the actual color picker. Use a file operator to bring this in. Okay, I'm gonna browse to where my leaf model is. There we go. And the leaf that we have here looks a little bit like this. Okay, so it's a little bit better than the one that we had before. Okay, if you look at the ones that we have over here, oops, look at the ones that we have over here, you will notice that they're pretty plain. Okay. All right, so from the class where we did the copying, you remember that we can copy objects at different point locations. Well, we can do the same thing here by simply adding normals to the leaves. Okay, so in the way we'll have actually point normals. And then actually doing a primitive operation. Okay, so this is like caveman primitive, basically. And I'll show you what this does. The primitive operator just allows us to do different operations on primitives, okay? In this case, polygons. But what is actually very useful is to do this. We can actually select, turn on to transformation, okay? And you can see like all the points on my little primitives here. What we can do, which is really neat, is that we can scale each primitive inwards into their own axis. Okay, so we can say I want to scale this to 0.001 on the x, 0.001 on the y, and 0.001 on the z. And what that gives me, if we look at this, is that for every leaf, I end up with, let me see if you can see a little bit better here. For every leaf, I end up basically with a little point in the center of a leaf, which is really awesome. Very cool. So now all that we have to do with this, now we can use this to actually copy our leaves into it, okay? We gotta be careful though, because if we look at the point numbers here, you will notice that I have more than one object, I have multiple points on top of each other because these things came out of being 6 points, okay? So before we do that, we'll put a fuse operator. Okay. I want to keep my normals the way they were. I don't want it to change it, but I want to keep degenerates. They're really not they're asking if you want to remove degenerate primitives, and obviously primitives that have 0 area, basically they are not, they are degenerate. But in this case, I want to just keep I'm fine with keeping them because I want to keep the single points that they generate. Okay. So now I have a single point for every leaf that I had. Now we can simply use, here I'll color these two guys yellow so that we can see them a little bit more clear. can simply do a copy operator. Okay, and when we do the copy operation, you will notice that every leaf now is copied where my old leaves used to be, which is pretty cool. Awesome. Now the art director, as you can imagine, wanted to color this a little bit more green, so we're gonna go ahead and actually add a little bit of green to this. Go maybe with this kind of green right here, and a little bit less saturated and a little bit darker. And now the last step is to simply merge your new pieces of the tree. Okay, so all that we have to do is to select this and put a merge operator. No, okay, forgetting to actually close the color editor there. And then on the merge operator, we'll just keep bringing in all of the different pieces of our tree. One more. And here is our improved tree for the art director. Okay, last thing we're gonna do is to put a null node, which is gonna be my out operator. Okay. In this particular case, instead of using a null node, I'm going to use an output operator, which is a more proper way to actually set up an output for your node, especially if you're using Houdini 14 and higher. You should really use the output nodes. Very cool. All right, so this actually completes our tree. And just to quickly recap, we started with this tree, which the art director wanted to do some modifications to. We use connectivity sub to separate out all the actual, I'll make this smaller, to separate out all the actual branches into with an attribute, so that we'll have an attribute per branch and per leaf. Okay. We promoted to see which one was the branch that had the most polygons. Okay, so by actually seeing what was the actual level of what was the level of connectivity, which one had the actual attribute, the most, which attribute was the most popular in between all of these from the connectivity operation, and we use that to separate our main branch of the rest of our tree. Then we actually use the group operator to, we use it with edges first to find all the polygons which had all border edges, and then convert it to primitives to isolate the border edges that were down here. Okay, from there we kept our leaves, and then we separated our rest of our branches. Okay, to separate these guys, we use a polysoup operator, which makes a single primitive from each one of these polygons. Just to actually make that super clear, if we zoom in very closely here, you will see that every face has a different ID. When we go to the polysoup, faces have, and a single branch have the same ID. Okay, it's taking our connectivity attribute and combining all of the branches into single primitives, so that we can use the measure to measure the total area of each branch. Okay, and once we have that, we use an attribute promote to then promote the area to get the maximum area, and then from there we use a blast operator to separate these guys, which are the ones that have the most area, from these guys, which are the ones that have the least area. Once we have that, we will simply do the art director's requested changes, which include a mountain operation to give a little bit of noise and adding color to this. We did the same thing to the main branches here, and we did the same thing to the mini branches here. For the leaves, we went ahead and actually wanted to copy our new leaf into all of the leaves. And to do so, we actually added normals to them, so that it will have actually some direction for each one of the leaves. And we use a primitive operator to actually collapse each one of the points into a single point, which we can see a little bit more clear here. And then a fuse to actually make one point out of those 6 points. Okay. The copy operator then allows me to copy all the leaves into each one of the points, and then we added colors to those as well. Finally, we merge all of them into one, and that's our final output node. Okay. Alright, well, thank you for watching, and we'll see you in the next lesson.